we're going to find the derivative dy dx. But now my x's and y's are all mixed up, so I need to use implicit differentiation. We're not going to leave negative exponents or complex fractions. The operation that we are applying is we are taking the derivative with respect to x of x squared plus xy minus y squared. And if we take the derivative of one side, we are also taking the derivative of the other. Remember, this piece right here is an operation. So this is telling me to take the derivative, and it's telling me to take the derivative with respect to x. So now I'm going to do that, applying the rules of implicit, because x and y are all mixed up. So we're going to say 2x, and then you're going to take the derivative of whatever variable we are working with. The derivative of x is dx dx. So technically that is 1. We'll reduce that shortly. The important part here is that we diagnose this as a product rule. So then we'll do plus y times the derivative of x, which I'm going to write as dx dx, plus x times the derivative of y, which is dy dx. This is the piece that I'm trying to solve for. Do not lose track of that. Dy dx is going to give me the slope, the change in y over the change in x at a specific point. So now I still have the minus 2y. Again, dy dx, because you always take the derivative of the variable that you are working with. And when you take the derivative of 3, you end up with 0. You have to have an equation, so don't let yourself lose track of that either. You always have to have an equation to work with. So now I'm going to take that and I'm going to start to maneuver. This is equal to 1. This is equal to 1. So my concern is that I have 2 dy dx's. So remember, I want all my dy dx's on one side. So I'm going to have x dy dx minus 2y dy dx. The parentheses aren't necessary, but they help kind of define it. And now I'm going to subtract 2x and y to the other side. So I'm going to have minus 2x and minus y. At this point, we want a GCF. So we want to factor out dy dx, and that's what I'm ultimately going to solve for. So now algebraically, all I need to do is divide by x minus 2y. So divide this by x minus 2y. So I'm feeling pretty good about my setup. Here, let me change this here. So I've got dy dx equals negative 2x minus y over x minus 2y. This is fine. If you start to move stuff left to right and you end up with different signs, you can also write this as positive 2x plus y. And then as long as all the signs are opposite, so positive 2y and a negative x on the bottom, sometimes that's a little easier to look at, and it certainly eliminates potential sign errors when dealing with especially a negative in the front of a fraction.